Something I've been doing lately that's a lot of fun is getting old hardware, old computers, and hooking them up to a Wi-Fi modem emulator so you can get online. And here is a really cheap and fairly easy way to do it. So let's talk about modems here. I've got sort of three different types of modems here, but they're all actually the same thing. Let's talk about the hardware requirements here. So this right here is a microcontroller called a ESP8266 board. It's also called the Node MCU, and it's also called the LOL1N or LOLIN. I'm not really sure. I've seen it both ways when I've looked it up. But anyways, ESP8266 board and one of these MAX232 RS232 adapters. You can see here, I've just got them attached to a piece of breadboard, just soldered through here, and I just ran some jumper wires. It's really simple. You've only got 4 connections you got to make: power, RX, TX, and ground. So this guy here I made is sort of a little stick you can just kind of put on the back of various computers that have a port on the back. This one here is a Commodore user port adapter. Same thing, I just stuck it to a piece of breadboard and ran some jumper wires across to hook up RX, TX, ground, and power. And then the latest one I made, I recycled this case from an original dial-up modem. I can take a look inside. You can see on the back we've got the ESP8266 board and the RS232 DB9 adapter, the MAX232 board. And take a quick look inside here. Just 2 screws to get in here. Alright. So, same thing, ESP8266 board hooked up to RS232 to TTL adapter. The only thing I've done here that's a little different is I've put them side by side, and I've added LEDs for power, RX, and TX. Now, I'm not sure if I did it the proper way or not, but I just hooked up the LEDs for RX and TX right up to the RX and TX pins on the ESP8266. I don't know if there's a better way to do it or not, but it seems to work. I get the lights blinking. You'll have to look up for whatever LEDs you're using. This board puts out 3 or 3.3 volts, and you just have to see what the forward voltage is of your LEDs to figure out what resistor you might need. And this guy's forward voltage was right around 3 volts, so I didn't bother putting in a resistor for that one. It's still a little bright though. This power LED actually ended up being way too bright, and I should just put a new resistor on, but I was lazy and I just stuck a piece of tape over it for now. But at some point I'll desolder that and put a higher value resistor. Now, the first time you make one of these, you probably don't want to go ahead and solder it to a breadboard, because you might want to set it up a little differently, but the main thing is you want to see if you can get it to work first. So really, before you solder this microcontroller down, it's got pins on it already, the ones that I bought on eBay, but you can just use a jumper wire and, you know, hook them up onto here and then hook them straight into the pins. They're all labeled on here: 3 volt, ground, TX, RX. So just 4 connectors. And as far as running these traces, when I do put them on a breadboard, I've been using this stuff. I've seen it called various things, but I think most often it's called magnet wire. But it's this small plastic coated thin wire, and the nice thing about it is the soldering iron melts through the plastic, so you can just, you know, lay it out how you want it on there and just solder right to it and then snip off the extra. It comes in real handy running traces. That's something I saw on some other YouTube videos that I just started doing recently, and it's worked out quite nicely. So, okay, now on to talking about the software requirements for this. So to get the software installed on this is not too difficult. You just have to get a micro USB cable and plug it in, and plug the other end into your computer. And I've been using the Arduino IDE to install the software on here. You have to make sure you have the correct board libraries, and in Windows you need to select the correct COM port, and in Linux you need to select the correct T2i USB port. But yeah, it's just a matter of plugging this in, flashing the firmware to this guy, you hook it up to here, to the 232 adapter, and then you're good to go. So let's take a look at the software for flashing the firmware onto this board. So I got my components on eBay. I believe you can get the same thing from Amazon. But here's the Node MCU board on eBay, and this is the TTL RS232 board. As you can see, that's about $6, that's about $5, so for around $10–15 or so you can make one of these. And before I get started here with the software aspect of it, I just wanted to do a shout out to my friend Kirk. He's the one who showed me how to make this Wi-Fi modem. You should check out his channel on YouTube, Kirk's Computers. He's got a lot of really great vintage terminals and stuff. He uses similar types of modems to get online with. So this here is the firmware that I've been using for my ESP8266 Wi-Fi modems, and I'll put a link in the description for these. But this is the one that I'm most familiar with right now. I guess it's based on a couple of other original versions, but the old net one is the one that I've been using. Another one that I recently heard about was this Z modem one. I've got that one uploaded to one of my modems, and I just started playing around with that. Okay, so I've got Arduino IDE open here, and the first thing we need to do is a little bit of setup. So you're going to want to check to make sure you have the correct board selected. I've got this ESP8266 boards library in here. If you don't have this, you'll probably have to go into your boards manager and then add in the ESP8266 boards. That way it'll show up properly. So for the board that I'm using, this is the one I've been using here, the ESP-12E module. It actually says that right on the Wi-Fi module on the board. I believe I got it working with this generic one as well, but we'll go with what I know works. You're also going to have to set up the serial port. I'm using Linux, so this is TTY USB 0. If you're on Windows, it's going to be COM1, COM2, COM3. You'll just have to open up your device manager and figure out where it's connected to. So to hook up the ESP8266 board, you just plug your USB cable into the back of it, into the micro USB, and then plug it into the USB port of your computer. Okay, so now I'm going to open up the modem firmware here, and I've got my board picked, got my port picked, so I'm going to go ahead and upload the firmware. So first it's going to compile it, and then it's going to attempt to upload it. If you have issues getting it to upload, you might have the wrong port selected or the wrong board. I've made the mistake several times of picking the wrong board. and then it tries to upload and then fails and gives you a weird error message. So just make sure, try a different board if the one you picked didn't work. Let's see here. Alright, we're slowly but surely uploading. Just give that a second. Okay, so now we've got the firmware uploaded to the board. Now, one other thing I should mention, if you're having trouble getting your 8266 board to program, it's possible that you might need to use this Node MCU flasher. It flashes it to allow it to have firmware uploaded to it. I'm not sure if this is something that you might need for if you end up with an older board, but the boards that I've gotten lately off of eBay, I haven't had to use this flashing tool. I've been able to just immediately go into Arduino IDE and just upload the firmware, and then we're fine. So just wanted to put that in there just in case you're having any issues getting the firmware uploaded. So now the next thing we're going to do is we want to test and make sure that our modem is working before I try hooking it up to a vintage computer. So to do that, we're going to use a program called PuTTY. So PuTTY's really cool. You can do SSH, Telnet logins and everything, but we're going to use its serial function, and I'm on Linux again, so this is TTY USB 0, and if you're on Windows, you have to figure out which COM port you're on. Now the modem firmware defaults to 300 baud, and you can change that to match whatever computer, whatever setup you're trying to get. So we've got that set, and we're going to go in and turn on local echo and turn on line editing. And just so you guys can see it a little better, I'm going to turn on adjust the font to make it bigger, and then we're going to open it. So now when you first open up your serial connection, which you're actually at this point just going through the USB cable, you hit enter, and then the modem will greet you. So the first thing it's going to do is tell you configure SSID and password. SSID is your Wi-Fi network's name, and your password is your Wi-Fi password. But how do you do that? If we type AT question mark and hit enter, then it will give you a list of commands. Now this is using the old AT style commands, which was actually used with original dial-up modem. But this emulator still uses AT commands. So if we look over here, set SSID is AT $SSID equals, and then you put in your Wi-Fi network name, and then to set the password, AT $pass equals your Wi-Fi password. And this is loading in really slow because it's defaulted at 300 baud. So yeah, just for example, AT $SSID equals my Wi-Fi network. And then it says, okay, AT $pass equals my Wi-Fi password. And once you get these set, you can do AT and W, which saves your settings so that when you power off the modem emulator and power it back on again, your Wi-Fi network's name and password will be saved in there. So let me go ahead and do that real quick. So I paused the recording there for a moment just to put my Wi-Fi network password and stuff in. If it shows it in plain text as you're typing it in. But anyways, once you get that installed or typed in, you're going to type ATC1 and hit enter, and that's going to connect you to your Wi-Fi. And if it doesn't connect, just double check and make sure that you set your Wi-Fi network name or your password correctly. So I'm connected to my Wi-Fi now, and let's see if it'll actually let us dial into a BBS. So to dial into a BBS, we're going to use the ATDT command. This was actually used with real dial-up modems, but in this case it's actually using telnet through the simulator. So we're going to do ATDT bbs.retrocampus.com. And there we go. So now we've got it set up and working. We know it's working through the USB cable. So the next step will be to actually hook it up through the serial port, through the TTL RS-232 adapter to a vintage computer, and make sure that's working. So to demo this modem here that I just flashed the firmware onto, I'm going to use this 1986 Toshiba T1100 Plus. You can see I've got the serial port cable plugged in, and it just uses the micro USB for power, so you could plug it into a phone adapter or whatever. I've actually just got it plugged into a power bank. So let's take a look at what we can do here. Alright, let's do a DIR here on B drive. And you'll see I've got MSK316. This is Microsoft Kermit. So let's go ahead and run that. Takes just a minute to load here. Alright, so now we're in Kermit. Like it says, you can hit question mark for help, and it'll bring up a whole list of commands here. Now remember, our modem is set at 300 baud stock when you first load the firmware onto it. It's also set for 8N1. So first thing we want to do is set baud 300, and then set speed 8. Or no, set display 8. The 8 is the 8 and 8N1. Then to connect, you can either type connect or just hit C, and you'll see here that we're in Kermit. I've already got the modem hooked up, and if we hit AT, it'll say OK, because it's already gone through and connected to Wi-Fi. You'll see the Wi-Fi message scroll through when you first hit enter after you connect to Microsoft Kermit. Now 300 baud is pretty slow. Let's see if we can get it a little faster. So we want to do AT $SB. Let's try 9600. Okay, now the modem's going to be at 9600, but Kermit's still at 300. So if we hit Alt X, do set baud 9600, hit enter, and then hit C to connect again. Do an AT, and we get OK. So yeah, we're going to be going a little faster than the 9600. Again, if you hit AT question mark on the modem, it'll bring up all of the different commands you can use. And then so for an example here now, let's connect to something. There's a sort of a 70s, 80s hacker game called Telehack. If you're not familiar with it, you should look into it. It's pretty fun. So we're going to do ATDT telehack.com. All right, so we're connected over Wi-Fi. Here's a list of commands. If you create an account, you can log in and there's lots of documentation. If you've never heard of telehack, you should look into it. It's actually really fun. Let's see, one thing we can do here. Hello. And in telehack here, you can do dir. Oh, nope, not unless you log in, but you can hit question mark. It'll show you a list of commands here. Then we can type exit to get out. And let's try another one. PBS. And now we're connected to Fostex, level 29 BBS. I am a visitor. Let's leave it at that. Let's leave it at that. All right, so I want to hit O to log off. Do you really want to log off? Yes. I just wanted to show you one more thing in Kermit. If we hit at the bottom, you can see here Alt X is escape, help is Alt H. It also tells you that we're at 9600 8N1, and right now we're emulating a VT320. So I'm going to hit Alt X, and we can do set terminal type, and if you type a question mark at the end of that, it'll give you the list of all the different terminals you can emulate with Microsoft Kermit. So we'll do set terminal type VT102. Now when we connect, we're emulating VT102. So yeah, that's fun. I hope this will help get some more people online with some of their older hardware. Thanks for watching.